Hi, in this video we're going to talk about formation of acetals from carbonyl groups using alcohols. So this down here is an acetal. It's a COCOC group. And to form it, we react this kind of thing, this carbonyl, and by the way, this can be a C as well. It doesn't have to be an H, with alcohols twice in order to create this acetal. And this heme acetal is just half an acetal, so it only has COCO. There's no C here. So the first step is this O has to grab a hydrogen. And the reason we need to do this is because methanol is not a strong enough nucleophile to react with this position right here. So we need to make this a better electrophilic position. And the way we do that is, as I said, use an acid to attach an H to this O, which gives it a plus charge, which can be moved down here with a resonance structure, making it a really good electrophile, because carbons with positive charges are good electrophiles. So that position is attacked, and you create this right here. And if you count the electrons, oxygen has one lone pair, which is not shown right here, and 3 bonds. So 6 minus 5 equals 1. That's plus 1. So it wants to be neutral. So it drops this H, some base grabs it, or actually this can grab it right here. But in this case, it's not shown. It loses this H and the electrons go down to the oxygen and making it neutral. And you have your heme acetal right here. And just to be clear, this O has become a hydroxyl group. So that's what this O has become right here. It's not this. To recap, first step, use your acid to attach an H to your O. The methanol attaches. The electrons from the double bond go up. You have this, you lose your H, and you have your heme acetal. Second big step rather, is your OH has to leave. In order to do that, it must become an H2O, because OH is a bad leaving group. And to do that, just grabs an H floating around the solution, and that's what's happening right here. And it leaves, and this double bond, or this lone pair, creates a double bond right here. And you're left with this structure right here, which should look pretty similar to this structure up here. It's a carbon double bonded to an O with a plus charge on it. That means you can draw the resonance structure with a plus charge here, making a good electrophile, and the nucleophile can attack. This lone pair, or rather electrons in this double bond, move up to the oxygen, and this becomes this right here, and this becomes this right here. And the last step is the H leaves, and the arrow shows electrons moving onto the oxygen, creating this neutral compound right here. So to recap this formation of the acetal from the heme acetal, you have to lose your OH by making it into an H2O. This lone pair moves down to form this double bond right here. And then you have this unstable ion. Unstable because it's very reactive with nucleophiles because of the resonance structure with a plus on this carbon right here. And then the alcohol can attack, and you have this little thing right here. It's positively charged, so you lose this H because the base comes and grabs it, and you're left with this neutral molecule right here. So if you can understand the steps, you don't have to memorize anything. Just know what's going on and why stuff is happening. And one thing is, H2O is actually produced as a byproduct in this reaction. Something you should have noticed, meaning that you can drive the reaction backwards by adding H2O, or you can drive it forwards by removing H2O. Think about it in terms of Le Chatelier's principle, because this is a very kind of unfavorable, well, not really unfavorable, but it's a reversible reaction, so it doesn't really go all the way like some other reactions do. So you need to do everything you can to make it react. And what people do is distill off the H2O created in this reaction to keep the reaction going forward. Hope you learned something. Thanks for watching.